today's lesson is how can you switch between the forms? How can you switch from one form to another? Why do you need to switch from one form to another? Maybe I gave you a form and I asked you for something that another form is good for. So you should go from that form to the good form. Okay? So, in other words, is there a math way to go from one form to another, just in case you need to use and work with a form that's different from the one that the question gives to you? The answer is yes. Here's a quick diagram to quickly tell you how to go from one form to the other. Okay, everyone? So, let's look at this. What's this shape? What's that shape? A triangle. Why is it triangle? Because we have how many forms? Three, exactly. One form is here at this corner. One form is here. One form is here. Okay, everyone, pencils down. So let me just basically tell you the process, and then we're going to write things on each one. Now, can you go? Everyone, come on. Can we go? You don't know the answer. So I'll tell you the answer, and then I'll tell you the name of the process. Can you go from vertex to standard? The answer is yes. So I want you now to put a check mark on this right here. Everyone, go ahead. Check mark. I'll go with green. Yes, you can. What's the name of the process? What's the name of the process that takes you from vertex to standard? In general, that's how you change anything. But what's the name of this process? Expanding. Everyone, I want you to write expand or expanding. Go ahead. Expanding. Okay. Can you do the other way? Can you go from standard to vertex? Yes, you can. Yes, you can. So I'm going to put another check marks in here. However, listen up. Hold on. This way of going, I'm just going to tell you what the name is, but you're not responsible for it in this course. In grade 12, okay, so everyone, look. In this course, I will give you a what? I'll give you a vertex form and ask you to switch it to what? Form. In grade 12, Mr. Fonseca, most likely, because he's the one always teaching grade 12 college, is going to give you a what? Form, and he's going to ask you to switch it to what? Vertex form. I'll tell you just today the name of that technique, but you are not responsible for it in grade 12. It's called, and this is, everyone, let's put the check mark here, because I need, it's a long name. It's called, I don't think anyone has heard of it before. It's called completing the square. Has anyone have heard of it before? Completing. Okay, good. Completing, everyone. I want you to write just com, and then put dot, the square. Completing the square. Come on. Completing the square. The most I could ask you about completing the square is a true-false question, like on the quiz. But I cannot actually give you an actual complete the square. It's not a part of this grade 11 curriculum. Grade 12, yes. Grade 11, no. Okay, so we're done one side of the triangle. Let's look at the other side. Can you go, let's look at this side. Can you go from factored to standard? Yes, you can. Also through expanding. So go ahead, put a check mark here, right here, and write expanding. Expanding. Okay, how about the other way? Can you go from standard to factored? Yes, you can. And the technique name is very simple, factoring. Factoring is a huge part of quadratics. Sorry, is a huge part of quadratics, and we will do a lot of factoring next week. And Mr. Fonseca will revisit and also extend on factoring in grade 12 if you happen to take it with him as well. Factoring. Okay, how many sides of the triangle are we done? 2. Okay, how about the third side? Going from factored to vertex or going from vertex to factored? Here's the sad news. No. Neither is possible. Yep, no way here, no way here. Which means what? If you need, well, but if you want to go from vertex to factored, what's the only way to do it? Yeah, thank you. You have got to go through what? Think about it. If you cannot go directly, then you have to take a what? You have to take a detour. If you want to go from vertex to what? You have got to go from vertex to standard by what? By, and then from standard to factored by. And if you want to go from factored all the way back to vertex, you have to go this way, which means you have to what? Expand it and then do the what? Which I cannot ask you to do. So that means in this course, I can never ask you to go from factored to standard, because half of the way you are not responsible for. Okay. What are we going to do today? Today we're going to do only one of these sides. Today we're only going to go from factored here to standard here. So what's the process name if you want to go from factored to standard? What gives you what moves you this way? No. Oh, sorry. Yes, expanding. My bad. Next week we go backward. Yes. All right. Let's expand, everyone. So let's expand. Now, I'm pretty sure some of you have seen expanding in grade 10, whether with me or another teacher. My way is always, everyone, I always show the lines. I always show the lines. What do I mean by show the lines? These lines. Everyone look. Here, 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 here. So, by the way, how many lines do you always show? How many? You always, why? Because each one of those two attacks each one of those two. So everyone, I want you to do this. One line that goes from here to here. One line that goes from here to here. And then one line goes from here to here. Here. And then one line that goes from here to here. It's always going to be 4 lines. Why? Because there are going to be 2 things in the first bracket and 2 things in the second bracket. By the way, what if my brackets had more things? Would I have fewer or more lines? Yeah, I would have more lines, but we're not going to do this in this course. It's always 2 times 2, or 2 things by 2 things in the bracket. Okay, so what do we do here? So what we have to do now, everyone, is multiply wherever you see a line. What does that mean? The first line connects x to the what? To the what? So it connects an x from this bracket to an x from this bracket. So all you have to ask yourself is legit this question. What's x times x? By the way, the whole process today is times. What's x times x? X squared. Remember, it's exactly like that. Technically, it's rule number 1. Some box to the power of 1 times, it's the same box to the power of 1. What do you do with the powers? We're never done with certain things. We always have to revisit. What do you do with 1 plus 1? You add them, so it becomes what? No, not this one. If it's 1 and 1, you get 2. So for everything, the first number we're going to write is, or the first thing we're going to write, my bad, y equals, y equals, come on, we can be done in 10 minutes. And then you got the rest of the period to yourself. Okay, where's my next line? I'm done 1 line. So x, guys, Ben, thank you. X hits x. My next x hits what? 2 with a what? What's x times 2? No. 2x. X times 2 is 2x. X times 7 is 7x. Just like when you say 2 times x. So everyone, positive or plus 2x. How much are we done? Half the work, because we are done 2 lines. Now we have 2 other lines. What's my third line? Does it connect what with what? Say again? You have to say the negative. Otherwise, you might what? Screw up the sign. So it connects -5 to what? So what's -5 times x? Just like plus 2x, but you write -5x. Almost done. Almost. What's exact? Hold on. Chris, please. Don't spoil the surprise. Relax. I love the fact that you're looking forward. Hold on. It's the joy of discovery to everyone. You said what here? Go ahead. And that's my last line. What's negative times a positive? Which one always wins? Negative always wins if they're different. Okay. Sorry, this is 10. If you leave it like that, and if this question is worth, like, let's say 2 marks, I cannot give you more than a mark and a half. Because there's a cleanup step that always needs to be done. And it's so easy to do it. Why? Because it's always going to involve the 2 in the middle. It's never going to touch this one. It's never going to touch this one. It's always going to touch these 2. Do you know why it will you can never add the very first and the very last? Okay. Huh? Sorry? Because this is an x squared, which is a variable squared, and this is just a what? A single number. Sorry, they're not the same nature. Are those 2, everyone, are those 2 technically of the same nature? How many people say yes? They are, because all they are 2 times x, subtract 5 times x. What do you get when you have a plus 2? Forget the x. What do you get when you have a plus 2 minus 5? Gaining $2, but having to give back $5. You are $3 in the hole. You have a loss of $3, which means what? Is it positive 3x or negative 3x? Done. That's it. That's your final answer, everyone. Y equals x squared. All of this becomes what? Sebastian, what is it? Full marks. Now you claim full marks, and I can't say otherwise. Can someone tell me what's the proof that that expression is the same as the other expression? What is always the proof when we do these questions? What technique do I use, or what website do I use? Desmos. Let's use Desmos. Everyone, I'm going to just, okay. I'm actually going to, yes. So let me show you both. Oops, sorry. Oh, here. Come on. Can I move it? Ah, my bad. Okay, where's Desmos? Desmos right here. Sorry, I'm not sure why I'm not able to. Okay, what's my, everyone, what was my original factored expression? Come on. Y equals, hold on, let me just move this. Okay, Y equals, bracket. Keep going. X, negative 5, close bracket, open another bracket, X plus 2. There we go. Is this a parabola? Of course it is, because it was factored form, so it's legit. Now I'm going to write the other one. And if they don't perfectly line up, I should not be teaching you. Let's see. Yeah. No one is too smart for a proof with Desmos. All right. Y equals. What did we get? The x squared after expanding minus. Are they the same yet? No, they're not. They're off. What do I need to put here? Minus. Ready? 1. Are they the same? Yep. Red, blue, red, blue, red, blue. They are the same. Done. That's the proof that your expansion is correct. Okay, let's do the next one. Can someone tell me how different is this one than that one? I mean, it is the same structure, but there's a slight difference. Sebastian? Yes. It's not a single x with a 1 and a single x with a 1. There's a 2 here and a 4 here. But does that change the fact that I have to do line? Never. Never. I don't care how fancy it looks. Do the line. All right. I'm going to use a different color. Line here, line here, line here, line here. And I'm going to zoom in right now. Okay. My first line hits what with what? Or connects one with what? 2x with what? Okay. What's 2 times 4? 8. And what's x times x? You got it. All right. Now, I have to do this line. What's 2x times 5? Forget the x. What's 2 times 5? It's 10. So it's plus 10x. Keep going. What's minus 4 times 4x? Negative 4 times 4 is 16. And there's an x that you cannot control, and it has to be here. One more. What's minus times a positive? Negative wins. Which two do you clean up? The far two or the close two? The middle two, the close two. What do you get when you have to give, when someone gives you $10, but you have to give 16 back? Negative 6 in the hole. Yes. Sorry, 6 in the hole, or negative 6 loss. There we go. So my final answer has to be written like this. Y equals 8x squared. By the way, just so you know, everyone, when you do a Google form, I don't need to see, obviously, you're not going to be able to write this curve or this bracket on the Google form. I'm just telling you what these two boil down to. Just write this line for me and then this line. No need to show me this. You can't show it anyway. I just show it today. Minus what? 6x. And this drops down. Done. That's it. What's the proof? Desmos. It's 2x. 2. Why is it 2x minus what? Come on. 4. And plus. And this one became uh-huh. 100% matching. Last one. What's the problem here? Come on. Abu Bakr. There's a number outside. Here's my question to you. Do you think I should have paid attention to this number right at the beginning or leave it at the end? Trust me, it will be so much easier to your right. Leave it at the end. You know why? Because your numbers are going to stay what? Small until the end, and then you expand them. Okay? Leave the minus 3. Do not do anything with it, as if it doesn't exist. It's still there, but as if it doesn't exist. So, where am I going to put my lines? Here, 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 and here. All right. So, one line, 2 lines, 3 lines, 4 lines. Okay. So y equals minus 3. Hold on, everyone. I need a bracket now because all of this has to be after the minus 3. So the only difference now is that I need a bracket, and then I'm going to clean the bracket. Yeah. At the end. At the end. Yeah. By the way, some teachers might tell you, no, multiply this one here, so it becomes minus 3x minus 9, and then do this one. I find out that it's easier to do the brackets first, and then you just multiply everything once by minus 3. Okay, what's x times x? X times x, x squared. Okay. What's x times negative 7? Negative 7. What's positive 3 times x? Positive 3x, yep. And what's positive 3 times minus 7? Who knows 3 times 7? 21 with a negative. Should I put the minus 3 in now, or should I clean up first? Clean up. I would rather multiply this by 3 things when I clean up instead of by how many? If you want to multiply the minus 3 now, it has to attack here, and here, and here, and here. Why? Clean these 2 up first. All right. So I'm going to use green. Yes. Okay. So y equals, do not touch the minus 3. Just write it. Bracket, bracket. X squared goes down. Can someone tell me what this is? Losing 7, gaining 3. Losing 4 or negative 4 with a minus 21. Now what do I do finally? Put the 3 in. By the way, you can put lines as well if you want. There's really no need. But in general, whenever something multiplies a bracket, we uh, favor to put the line. Sorry, that's not a good line. There you go. All right. Last answer. Y equals. Okay. What's negative 3 times x squared? Negative 3x squared. What's negative times a negative? What's 3 times 4? With what? With an unchanged x. What's negative times a negative? What's 3 times 21? 21 times plus 21 plus 21, 60. Full marks. That's it. Welcome to expanding. Never gets harder than this. Yeah, but I just want to do the Desmos and then I'll show you. So let's do Desmos, everyone. Sorry. Okay. What was the original bracket? Oh, minus 3. I'll just do it. Yep. Minus 3. What's next? X. Whoa. Big quadratic. Let's do the standard form. Minus 3. X squared. Then what? Plus 12x plus 63. Let's see what happens. What is it now so far? By the way, do you see how they are the same shape? But they're not lining up. It's like 2 hands. They are the same shape, but they're not lining up. I need to drag one of them up. Ready? Plus 6, 3, 2, 1, go. Boom. Done. Line up. Perfect. And that is today's lesson.